Hello and welcome to today's class. For this class, we're talking about the concept of differential equation. Let's look at the study of differential equation and let's see how differential equation works, right? So first, we'll look at the definition of differential equation and some terms used in the study of differential equation ranging from the order linear, we have the homogeneity and etc. We'll look into those concepts one after the other and see what we get. All right, let's start with the concept of differential equation. By definition, differential equation is simply an equation that contains at least one differential coefficient. So when we talk of differential equation, it's simply an equation that contains one differential coefficient. By the word differential coefficient, we mean whenever it contains um, dy over dx or the squared y over the x squared or the cube x over the s cube etc. So when an equation contains at least one differential coefficient, if the equation contains y over the x or the squared y over the s square or the cube x over the s cube, it's simply what there is simply a differential equation. All right. Next up, I want to understand the definition of differential equation. Let's I want to understand the concept of differential equation. Let's look at something called the order of the differential equation. So, ready, please. Order of a differential equation. So, when an equation contains at least the y over the x or the square over the x square or the cube x over the s cube, it's said to be what the a differential equation. Let's now look at the order of a differential equation. The order of a differential equation is equal to the highest differential coefficient involved in the equation. So when I say the order of differential equation, it simply means a differential equation that has the highest differential coefficient, right? By the word differential coefficient there, we mean the square there. Look up. Let's say I have, for instance, let's say I'm given that y is of x is equal to dy over dx or the squared y over the x squared or what there the cube y over the s cube. Observe that I'm having this right and I'm saying that the order of a differential equation is equal to the highest differential coefficient involved in the equation. Let's assume that this is an equation, for instance. Now the highest differential equation coefficient here becomes what? Becomes 3. Yeah. So when you hear the word order of a differential equation, it's focused more on the differential coefficient that has the highest power. Let's put it that way, right? When it comes to order of a differential equation, we're looking at differential equation that has the what? Highest power in what? In a differential equation, right? So that becomes the concept behind order of a differential equation, right? Let's look at the concept of degree of a differential equation. Let's look at the degree of a differential equation. All right, differential, please. Let's look at the degree of a differential equation. The degree of a differential equation is equal to the degree or power or index to which the highest differential coefficient is being raised, right? So when it comes to degree of differential equation, it's simply the highest power or index or degree to which the highest differential coefficient is being raised. That becomes your definition for degree of a differential equation. Let's look at an example that contains the concept of order of a differential equation and degree of a differential equation. Let's look at how this thing works, right? So I'll give you an example. We'll take an example now together and look at how these two concepts works now. Example. Example. Example says that given the following function, find the order and degree. Given the following function, find the order and degree. Given the following function, find the order and degree. For this question here, we are told to find the order and degree of this differential equation. Before I start solving, or before I start finding the degree and order of this equation, my very first task is that I'll ask myself, is this equation, is it an equation, is it a differential equation? Of course, yes. Why? It contains the s over the t, irrespective of what is there, either the s divided by the x or irrespective. So far, it contains the s over the t. It contains this, the squared s over the t squared, as you can see, the cube y over the x cube. So these are what? All these are called what? Differential equation. Why? Because it contains at least differential the y over the x, and so I have this one here. Having identified that this is a differential equation, how do you get your order and your degree? We said find the order. What is the order of this one? What's the order? Order and order. Let's look at number one, please. Let's get the order of number one and the degree of number one. We said when it comes to order, when we define order, we said the order of a differential equation is the equation to the highest differential coefficient. When it comes to order, the idea of order is that you look at this equation here, which one has the highest differential coefficient. So this is the x over the t. Perhaps the idea is that this is the 1x over the t to power 1, if you want to, right? You see the same thing as if I want to take it in this pattern, this x squared over the t squared, or the cube y over the x cube, so now become the 1x over the t to power 1, right? But here now, my order here, we said order goes with the what? The power to which the differential coefficient is being raised. The power here is 1. The power of this differential equation is what? Is 1. So here in this question here, I'll have what is first, because my first order. So we said identify the order and degree. So this becomes what? First order, comma. This becomes first order. Let's consider degree. We said the degree of a differential equation is simply the power to which the differential coefficient is being raised. So if I take this in a bracket now, the highest power here is what? If I take this in a bracket this way, the highest power now here is what? Is 1. So the power to which the differential equation, the differential coefficient is being raised is what? Is called degree. So our first order, first degree. So I have this one here. So we said find the order and degree. So this equation here, it has first order and what? First degree. Let's look at this one. For this one here, how do you solve this man? We said get the order and what? Get the order and degree. The order here becomes the coefficient, the differential coefficient that has the highest power. This one is this one is squared. This one is what? Having the power as 1. Which one of these two has highest power? The highest power, of course, is what? Is the squared x over what? The t squared. So the order here becomes 2. That becomes second order. So the power becomes the second order, right? Now, what's the degree? We said the degree, when it comes to degree of differential equation, the one we consider now as the order, what is the highest power? What is the degree to which it is being raised? Is what? Is 1. So I have, if I take this in the bracket this way, the degree that we here is 1. So I have first degree. So I have this one here. So this one is called second order and first degree. Let's consider this one. My order here becomes what? The square here. So I have this one is called second order and what the first degree. All right, sorry. Number 3 has a square here, please. So for number 3, I'm having a square here. So this one is a differential equation, right? Sorry, differential coefficient that has what? Highest power has been 2. So it means that my order is what? 2. So my degree, the differential coefficient, right, is being raised to a particular power, which is 2. So my degree here is what? Second degree. So it becomes how to solve this particular problem. Looking at this equation here, what's my order? My order is what? We said when it comes to order, I'm looking at the differential coefficient that has highest power. So this one has the highest power, cube. So I have third order, third order. Next up, we are considering the one that no, we said this is third order, right? This is the differential equation that has highest power. Now I'm still focusing on this one to get my degree. What is the degree to the highest differential coefficient here? The degree here, if I bracket this like this, the degree is 1. So I have third order, first degree. First degree. This becomes how to solve this particular problem here. So note that a differential equation is an equation that contains at least one differential coefficient. So to get order, check your differential coefficient. What's the power to which it's being raised? This power here is what? Is 1. That becomes first order. How do you get the degree? Check the highest power to which the differential coefficient is being raised. Right? So if I bracket this like this, the highest power here is what? Invisible 1. So my degree there is 1. Looking at this one is is a differential equation. Sorry, this one is what? A differential coefficient that has its highest power as 2. So that becomes 2 order. The degree to which the differential coefficient is being raised is what? Is 1. So I have 1 degree. This one, the degree is what? 2, second degree. The highest power here is what? 2. That's second order. This what? Third order. And what the highest power to which the highest differential coefficient is being raised is what? Is 1. That's all this particular problem here. So this becomes how to identify your degree and order of a differential equation. All right, let's look at homogeneity of a differential equation. So let me call differential equation, let me call it DE. So a differential equation is said to be homogeneous if it is equal to 0 and non-homogeneity when it is not equal to 0. So when a differential equation is equal to 0, it's said to be what? It's said to be what? The homogeneous. And when it's not equal to 0, is what? It is non-homogeneous. Right? So all right. We'll take an example to further explain the idea of homogeneity. So when a differential equation is equal to 0, it's called what? The homogeneous, right? When it's not equal to 0, it's said to be what? The non-homogeneous differential equation. Let's look at the concept of linear and non-linear differential equation, DE. Let's look at the concept of linear and non-linear differential equation. A differential equation is linear if the highest differential coefficient is raised to a power 1, except it is non-linear. So I'm saying that a differential equation is linear if the degree, if the highest power, if the highest differential coefficient is raised to power 1, right? As x, it is non-linear. So I'm saying that if the differential coefficient, if the highest differential coefficient is raised to a power 1, look at this one. The highest differential coefficient here is this one, abi, but it's raised it is raised to power 1. So this one becomes what? A linear differential equation. Non-linear is that if the power is what? Is 0, becomes what? A non-linear differential equation. Let's take some past questions and solve together. Right. The question says that give the name of the following differential equation. So how do you give name to differential equation? That's the question now. So before you solve this problem now, let's understand how to give name to differential equation. So to give name to differential equation, it should be arranged in terms of number 1, order, number 2, degree, and number 3, homogeneity. So if I thought to give name to a differential equation, here's how to give the name properly. Start with order. When you're done with order, move to degree. When you're done with degree, move to what? Homogeneity. When it comes to homogeneity, the idea is that when a differential equation is equal to 0, becomes what? The homogeneous differential equation. When it is not equal to 0, becomes what? A non-homogeneous differential equation. Let's name this one here. We said start with degree. We said the degree is the differential equation that has the highest power. This one here is a differential equation. This one here too is a what? Differential equation, right? Now, this is the squared y. This is the y. In between the squared y and the y, which one has the highest power? The highest power is what? The squared y. So I'll be having what there? I'll be having, to name this becomes what? Second order. I'm done with order. Move to degree. For degree, I'm considering the one I considered as my order, which is this. What's the degree to which this differential coefficient is being raised? That's 1. That becomes first degree. Finally, we said when naming, start with order, degree, and what? Homogeneity. For homogeneity, this differential equation is equal to 0. So when a differential equation is equal to 0, it's called what? A homogeneous differential equation. So perhaps you could add order, degree, homogeneity, and what? And linear and non-linear, right? Linear and what? Non-linear, right? So this becomes second order, first degree. So this equation, is it okay? We said that it's what? It's what? A homogeneous. Why? It's equal to 0. So it becomes what? A homogeneous equation, homogeneous differential equation. a homogeneous differential equation. So what of the linear? Please look up, look up, look up. To name, start with order, then I will ignore degree, please. Ignore the degree. Linear. Aha. So linear or non-linear? Consider the linear or non-linear, right? So I will ignore the degree. So when it comes to naming differential equation, start with order. When you are done with order, check the what, if it's linear what or non-linear. So I will ignore degree. We don't consider degree, but just know that degree exists. So look at this place now. What will I put as degree? We said the degree. Sorry, we said I'm going to put linear there. For linear, look up please. We said a linear equation is simply an equation that which its highest differential coefficient is being raised to power 1. Look at this now. This man is raised to power 1. So it's what? Is a what? A linear. A linear, what's it called? A linear differential equation. So this one is called second order linear homogeneous differential equation. Let's do this. Let's get what we get. For this one here, we said the first task, let's name it. We said get the order first. The order here becomes the one with highest differential coefficient. My S here is what? Cube. This one is the cube. So by having third order, when you are done with order, we say move to what? Linear. Let's get the linear concept. We say when it comes to linear, I'm checking my highest differential coefficient is this one, right? Is it the degree is simply what there is not 1. The degree is 3 here, so it's not 1 because what? A non-linear. If it was 1, it is what? Linear, but it is not 1, it is 3 because what there? A non-linear. Next up, we say consider what the homogeneity. So homogeneity works with if a differential equation is equal to 0. This one becomes equal to 0. That's why it's called homogeneous. But this one is not equal to 0 because what? A non-homogeneous. So have non-homogeneous differential equation. I have this one here. So this becomes third order non-linear homogeneous differential equation. So I have this one here, as you can see in front of you. So here is the concept behind the introduction to differential equation.